Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. Today we are going to look at the topic called motion and forces. On this topic, there are a few concepts which very frequently appear on exam. So let's quickly have a look at them. The first part of this topic is motion. When it comes to motion, there are two equations that you must know. First one being speed equals distance divided by time, and the second equation is for the acceleration. Which is acceleration equals change in v divided by time. Now because this is change in v, the same equation can be written in another way, which is acceleration equals v minus u divided by t. You just have to remember here that this u is your starting speed. We should use word velocity, but because in your exam the questions will be only in one direction, so you can use speed or velocity. They are both the same in your case. This will be your final speed slash velocity. Now which equation you will use in your exam will depend on the data that will be provided to you in the question. So reading question is extremely important. So I can say this is about using equation. The second thing that you need to know when it comes to motion is graphical questions. There are two types of questions which can appear on graphical questions from this section of this topic. One is your distance time graph. If it is a distance time graph, then you will calculate speed using this formula: y2 take away y1 over x2 take away x1. If you have a VT graph, then you will calculate acceleration using formula y2 take away y1 over x2 take away x1. But if you have a VT graph, it will give you one more quantity. It can also be calculated from this graph, and that would be distance equals area. Now you might be thinking, why am I writing this? If you look at the previous video, you will see we learned about 3 skills from the core concept topic. These are the skills which are being recalled. How do I know speed will be determined using this? Because I can see on y-axis I've been given distance, on x-axis I've been given time. So I'll do my check. So my check says check 1. What was check 1? You will do y divided by x. What is y here? It is d. What is x here? It is t. What comes out is your speed v. So speed will be calculated using this. I can do the same check on this graph here. I can do check 1 and I'll do exactly the same thing. What's on y-axis? This time it is velocity. What is on x-axis? Time. So if you divide velocity by time, you can see here velocity divided by time will give you acceleration. This time I'll end up with a, and therefore a will be worked out using this formula. Okay. Similarly, there was check 2. I can do check number 2. What is check 2? In check 2, we multiply y with x. So if I multiply d times t, I don't get anything here. So nothing will come out here, right? So this one will not work now. So we can't work out anything if we calculate the area under the graph for distance time graph. But for a velocity time graph, my check 2, if I do that, it will be y times x. This time on y-axis you have speed times time, and if you multiply them together, you will get d, which is your distance. Therefore, distance will be worked out using area. We will do one question on this in a minute, and it will make more sense to you. So you have to remember 3 things so far. You need to know how to use this equation. You need to remember your checks, and the third one is from a distance time graph, you will calculate speed like this. From a velocity time graph, you can calculate acceleration as well as the distance, right? But they both will have different formulas. Now, this is all about motion that you need to know for your exam. So these are the skills that you will be tested on. This is sometimes, there could be investigation question, right? So question may appear. on number 1. I can say rather than finding, we should say measuring speed. And the second bit I can say is measuring acceleration. Okay. So if a question appears, or if it states something like describe how you will measure speed or describe how you will measure acceleration, the first thing that you will do is you will list the equation, and then you will tell how you're going to measure the distance. Distance can be measured using a ruler. Time can be measured using a stop clock, right? Now there might be a bit complicated question when it comes to this section. So if I look at it, I can say A equals B minus U divided by T. For this section, we use light gates to calculate the speed, final speed, starting speed, and time. So what you will need to do is, I can say this is my table. This is my trolley with a card, right? This is my card, okay? Now I can say here, this will be light gate 1. I can draw another one here, which is light gate 2. So now what will happen in this case is I can say when this card will pass through light gate 1, it will record the time it will take to pass through light gate 1. When it will pass through light gate 2, it will record the time it will take to pass through light gate 2. And then at the same time, these two will also give you the time T3, which will be the time it takes for the car to travel from light gate 1 to light gate 2. Now, if I know this distance of card, which is width of card, can be determined using the ruler, I can calculate my starting speed. This is U, right? Because this is my starting speed, location 1. This will be V. So I can say U can be calculated by doing D over T1. V will be calculated by D over T2. I know the value of U, I know the value of V. I know the value of T3, which is the time it takes for the speed or velocity to change from one value to the second value. And this is how you'll be able to work out the answer. This could be a 4 to 6 mark question in your exam. So you just have to remember this, right? I will have a trolley with card attached to it. I can work out the distance of the card using meter ruler. I'll let this trolley pass through the light gates. The first light gate will determine the time it takes for this car to pass through it. Second light gate will determine the time it takes for this car to pass through it. And at the same time, these two light gates will give us the time it took for this car to travel from location 1 to location 2. Now I know the value of D. To work out the starting speed, I can do D divided by T1. To find out the final speed, I can do D divided by T2. So now if I look at this formula, I know the value of U, I know the value of V, and I also know the value of T. I can put these values in and that will give me the value of acceleration. Occasionally, a question appears in exam where they give you the value of acceleration, starting speed and final speed. And they ask you to find the distance traveled. In that case, you'll have to use this equation. This is provided on the formula sheet, but you have to remember what each quantity is. So V is same as final velocity. Remember, like I said earlier, speed and velocity in calculations in your exam are the same thing, but they're not exactly the same thing. We'll discuss that right towards the end of the session. This will be your starting speed, and this is the distance, right? Okay, so you have to remember x is distance in this case. One most common mistake that students do when they use this equation is they don't put the square on top of the values once they start substituting instead of V, U and A. So make sure you pay extra attention to it. There's one question that we will do on this section too. Now let's move on to the second part of this topic, which is forces. So what is it that you need to know on this section, forces? First one I can say is you need to know weight. What weight is? Weight is Weight is the force that the objects experience due to gravity, and there's equation for it. Weight equals mass times gravity. Okay, number one. Then I can say weight. Second equation is force, which is resultant force, okay, equals mass times acceleration. Mass times acceleration. Third one we can say is the force equals, because we know equation for acceleration from the previous topic, which is motion. So if I replace acceleration with that equation and start solving it, I'll end up with equation mv minus mu divided by t. Now you might be thinking, what is mv? So that's the fourth equation. I can say momentum is equal to mass times velocity. So the same way like we had equation for acceleration, we said, I can show you here, we had equation for acceleration, change in v over time, and then we wrote change in v as final takeaway starting. We can do the same thing here. We can say this is same, can also be written as force equals change in momentum divided by time. Okay, so we've got equation 1, 2, 3, and 4. Then there's there's another equation, which is stopping distance is equal to braking distance plus thinking distance, right? So you may be asked to do calculation questions based on these equations from this topic. And then there is one more that we need to remember, but that's not like an equation, that's a concept. What is that concept? The concept is conservation of momentum. Momentum. What is conservation of momentum? You will say total momentum before is always equal to total momentum after. Be very careful. I'm writing word total here, right? So it's the total momentum that you must state. It's not going to be like momentum before will be equal to momentum after. It is the total momentum before must be equal to total momentum after. Then there are three more concepts that you need to know. One is Newton's first law. Second one is Newton's second law. And the third bit is Newton's third law. This is of particular importance, right? So let's quickly have a look what do we mean by these, right? So if they ask you about Newton's second law, all you need to do is you just need to state equation. Fr, which is resultant force, equals mass times acceleration. This is Newton's second law statement. When it comes to Newton's first law, it says Fr is equal to 0, where Fr is resultant force equals 0, right? Then there will be, what will happen? This means your acceleration will be 0. Now when acceleration is 0, then there are two outcomes to it. You can move, it will stay at rest, or it will move at constant speed. Okay, you have to remember, and this is where a lot of people will make mistake, or they tend to make mistake, right? So make sure you know this, that it will not always stay at rest if resultant force is 0 or the forces are balanced. There's another option as well. If the object is moving, that will move at constant speed. Let's quickly have a look at Newton's third law. This is of immense importance to us. Why is it of immense importance to us? Because very frequently questions will appear on this, right? So you need to remember one. This is valid for collisions, right? So I can, it says every action has equal and opposite reaction. That's the Newton's third law, but you have to remember action and reaction act on two different objects. Okay, very, very important. So you can't apply Newton's third law if you consider only one object. So action and reaction act on two different objects. We need two objects, number one. Number two, action is always equal to reaction. And third one is action and reaction are in opposite direction. Okay, that's very, very important, right? Now in your exam, just like we looked at the other topic, there might be some investigation questions from the forces concept as well. So what is it that you can think of when it comes to the investigation type of questions? There could be question on this equation. This is from F, which is force equals mass times acceleration, right? So in this case, generally what we do is there are two options that we have to look at. One is where you change mass and record acceleration. In the second case, you will change force and you will record acceleration. So you will need to know how will you measure. Number one, how will you measure acceleration? We have done this on the last bit when we were doing motion, right? Number one. Number two, how will you change mass? Number three, how will you change force, right? Now the diagram that we use for this is similar to what we had for the acceleration, but in this case you will have, again, you'll have a trolley, and I can say here we'll put masses. Here you will have pulley, it will be connected to the hanging mass, right? Now again, we'll need light gate 1 and another light gate. Okay, now if you connect light gate to a data logger, it can give you the value of speed at this location straight away. It can give you the value of speed at this location straight away as well, right? So the light gates, or I can say these light gate, okay, light gates will give you U and V, right? They'll give you the value of U and V, plus they will also give you the time, right? So you can work out the acceleration from here. The next bit that we have to look at here is, so we've done this part, how to measure acceleration. How will you change mass? Now to change mass, what we do is, this is always added to the trolley, okay, while hanging mass stays the same. If you have to change the force, then you can't change the mass. So what you do is you will transfer mass from trolley to hanger, right? If you do that, then the mass of the system will not change, because you can only change one variable at one time. This is all that you need to know. Okay, this is all that you need to know from this topic. Now before I move on to the questions, there are a few bits to highlight. Let's quickly have a look at them, right? So you need to remember one thing about this conservation of momentum, that this is always true in a collision, right? So if two objects are involved and they collide with each other, momentum will always be conserved in your case, right? Then you need to think, remember one more thing, there could be investigation question based on this, right? So investigation question on this concept. So you will need to know what are the factors on which braking distance depends and what are the factors on which thinking distance depends. We'll do one question on this as well, and that will make things more understandable for you. Okay. This is all you need to know for this topic. Before I conclude this video, there are a few bits that I would like to bring into your attention because they are important. Number one is you have to remember, when it comes to conservation of momentum, it will always be true in any collision. So for any collision question that you come across in exam, you will have to remember one thing, that total momentum before will always be equal to total momentum after. And the last bit is, there could be a question potentially, there could be a potential question. Last bit, there could be a potential question on this equation usage as well, right? So they may ask you, what are the factors on which braking distance will depend, or what are the factors on which thinking distance will depend? Or they may ask you a question, how is stopping distance going to change for a given situation? We'll do a question on that too when I start working on the exam questions worksheet. That's all for this topic. Thank you very much. I hope you found this video useful. I hope you found this video useful. If you So for your information, to assist you with this, what I'll do to assist you with your learning, I've uploaded this. To assist you with your learning, I've uploaded this file as a PDF document in the description below. Right? So you can download this from there and keep it with yourself as a PDF copy. To assist you with your learning, I've uploaded this document as a PDF document in the description below. You can download it and keep it for your revision. I wish you all good luck with your exam preparation. Thank you.